Here we have an 80 loop coil inside of a magnetic field of 6.4 milliteslas, and we are going to move the coil to induce an EMF and then also try and find out what direction the induced current would go. Okay, so this is about Faraday's law and Lenz's law, so we're going to have to start with the basic expressions. And of course, this is all about changing flux. So I'm going to start by just finding out what the flux is to start with, when of course flux is BA cos theta. Well, I've got the magnetic field of 6.4 milliteslas, I've got the area of 0.0072 meters squared, but of course I also need to use the angle. Now of course the angle I want to use is not the 65 degrees between the coil and the field. The angle I want to use is the 25 between the field and the normal to the actual area. So that angle right there I want to use is going to be the 25 degrees. So if I do that and do my calculation, I can find out that the flux through my coil is about 4.18 times 10 to the negative 5 Webers. Then I'm going to take that coil and I'm going to turn it vertical. So now it's going to be situated like that. It's nice and vertical. So I'm going to maximize the flux. So I can then find my new flux, which is going to be my flux prime, so BA cos theta. Of course, now since it's vertical, cos theta is going to be equal to 1 because I've maximized the flux. So if I do that, I can find out that my new flux is 4.61 times 10 to the negative 5 Webers. Now, of course, it's not about how much flux you have. It's about how much your flux changes. So I've got to find out my change in flux. So I've got to take these two and find the difference in my flux. Now, if I find the difference in the flux by subtracting the two, I can see that my flux has increased by 0.43 times 10 to the negative 5 Webers. And now that I have my change in flux, I can use that to calculate my induced EMF. Now, my induced EMF expression is negative N delta phi magnetic field divided by delta T. Well, I've got my N value of 80 loops. I've got my change in flux right there. I've got my time, 3.5 milliseconds, and I can put them all into the expression. And if I do that, I get an induced EMF of 0.098 volts. And it is negative because the flux increased, and there's a negative in front of the expression because it is an induced EMF for the conservation of energy and that type of stuff. So there's my induced EMF. Now I've got to find out what my direction for my induced current would be. Well, if I take my coil started out this way, and then my coil ended up being this way. Now, when I did that, I increased the amount of magnetic field or flux going through it. I got more flux going towards the right. This positioning has more flux than this one. So since I created more flux going towards the right, in order to compensate, the coil is going to make more flux going towards the left. And if this thing is creating a magnetic field going towards the left like this, using my right-hand rule number 1, I can see that if this is the close side or closer to me, the current would have to be going in this direction. So my induced current would be going up the side close to me, wrapping around and coming back this way. So my induced current is going up on the side close to me and back down on the side far away from me.